I'm Jonathan. I'm one of the graduate TAs, and the purpose of this tutorial is just to kind of get you guys caught up with Java, with anything you aren't familiar with or comfortable with yet. So if you have any questions during my slides, just feel free to stop me and ask questions, and I can go back to stuff and try to clarify. So unlike Python or JavaScript, Java is a statically typed language. And what that means is when you create a variable or function, you have to specify the type of that variable, and it can't change during runtime. Function types require both the return type and the types of each argument. And types may also include attributes such as final or static. So here, an example function sum takes two integers and returns another integer. And the variable text is of type string, and it's marked final, which means that it can't change after it's initially assigned to. The value will stay constant. So data types in Java, there are two categories of types, primitive types and object types. There are exactly 8 primitive types, which are listed there. And then there are object types, which is everything that's not a primitive. So the main difference between primitive types and object types is that objects are references, which requires an extra level of indirection. So if you have a variable that's referring to an object, then it's actually pointing to a location in the heap where that object is stored, rather than to the object itself. Object types all extend the class object, and by convention, they begin with a capital letter. So I'm going to give a brief overview of object-oriented programming. So in Java, we can create new types using interfaces and classes. So interfaces can have methods, which are functions on a type. The methods can be given a default implementation or left unimplemented. But you can't create an object of an interface directly. And the purpose of an interface is just to represent the behavior of some type. Then, on the other hand, classes can have both methods and fields, which is, a field is just data inside of a type. And you can create a new instance of a class using the new keyword, unless the class is marked abstract. But use of abstract is discouraged. You can do pretty much all the same things, just using interfaces and classes, concrete classes rather. Abstract classes can have fields, unlike interfaces, but like interfaces, you can't instantiate objects.
I have a question. What does that mean, though, a default implementation? Like, what does that mean?
So when you make an interface, you list all of the functions that classes that implement that interface have to have, but you don't give a function body.
Okay.
You just have the name, the parameters, and the return type. You can specify a body using the default keyword, and then any class that implements the interface will use that implementation by default. So this is a simple example. Interface my interface doesn't have any members. Then class my class implements my interface. And then we can declare an object of type my interface using the new keyword and my class. So the type of this object is my interface, but when you actually create an object, you have to use a class. You can't instantiate the interface directly. Classes can also extend other classes that aren't marked as final. So what that means is they get all of the methods and fields that are in the original class, but they can also add new members. And they can also override the behavior of non-static, non-final methods in the base class. Classes can also implement interfaces. And what that means is they must provide an implementation for each method that doesn't have a default. So like I said, if the interface has a default implementation, then you can leave those blank or provide a new override. So here's an animal interface that has just one method, speak, and class dog can implement animal, and it gives the speak method a body which prints woof. We can then define a new class, noisy dog, to extend dog, and it also has a speak method. And then it can call inside the method super.speak, and because the superclass of noisy dog is dog, it will call dog.speak when you call super.speak. And then it can do other things. So in this case, it would print woof twice. And noisy dog can also add new methods that are not in the base class or interface. Any questions about any of that? So class members, both functions and data, can be either instance methods or static. So everything is an instance method or field by default, unless you explicitly mark it as static. So the difference is that every new instance of a class gets its own copy of instance fields, and to call an instance method, you have to call it on an instance of the object. Whereas with static, there's exactly one copy of each static field in a class, and you don't need an instance to call a method, a static method of a class. So basically, static members are Java's way of doing global functions and global data, because you can't have a function or a variable at the top level of a Java file. Everything has to be inside a class. And having static members is basically just a way of organizing those global data. So static methods are good. You can use those to perform some functionality related to the class that doesn't require a specific object of that class. Typically, non-final static fields are bad for the same reason that global variables are bad in other languages. So you usually want to avoid those. So Java scoping rules determine the visibility of code to other parts of the code. There are 4 levels of visibility. The default is package private, so if you don't specify the visibility with any of these other 3 keywords, then that's what it will use. And that means it's visible within the current package. So at the top of a file, you can say package and then a name, and that will determine what package the contents of the file are in. And that's just a way of organizing your files by functionality. So a public class or a public method is visible everywhere. Anything can see it, anything can use it. Protected is visible only within the class and subclasses, and private is visible only within the class, so even the subclasses can't see it. And you can use these scoping rules to separate your interface from your implementation. So you might have private data members and then have public accessors and mutators for those data. And again, you can only call a function or rewrite a variable if it is in scope. Any questions about that?
Can you explain again about the definition of package?
Yeah, so let me go to an example. I don't have an example in my slides. Okay, so this is the ilist.java. See at the top, package edu.rice.list. So that means that this file is part of that software package. So another file, list.java, is also in the edu.rice list package. And that's just a way of organizing your files into into cohesive units. So if you had a package private class, for instance, in list.java, or say in ilist.java, then you could use that class in list.java as well. Java also allows you to nest classes inside of each other. And inner classes have access to all of the containing classes members, including instance members. And the way that works is every instance of an inner class is associated with an object of the containing class, unless the inner class is marked as static. And having static inner classes is basically just another way of organizing your code. So, for instance, class A has a field string name, and then it has two inner classes B and C. Since B isn't marked static, it can access the name variable inside its own methods. Whereas with class C, since it's marked static, it can't access that variable. Any questions about that? Now, generics are something we've used a lot already in the class, and they enable the use of types as parameters to a class or a function. And they're useful for programming algorithmically or creating container types. So syntactically, the way you make a generic type is using the angle bracket notation with the type parameters inside. So in this example, T is the template parameter. And the name is arbitrary, but T is what we typically use. So the examples I have at the bottom, public interface ilist T. The T here is what says that ilist is a generic type. So when you use that type, you have to say what it's a list of. Similarly, the sum method at the bottom is a static method that introduces its own type parameter T. And the syntax here is you have the modifiers of the return type, followed by the template parameter, followed by the return type. So because this is a static method, if it's going to be generic, you have to introduce the type parameter in the method signature. And then you can use it in the rest of the signature. So we introduce T here, and then T is the return type. And it's also used to as the argument of the ilist parameter number list. Generics can also have multiple type parameters. You just give it multiple names separated by a comma. Now, the question mark is a wildcard, so it can stand for any type, but you can't refer to the type in the class or method. So I have two examples here, public static int length. So this is if we were to write a standalone function for finding the length of a list. The list could be of any type, and we don't actually care what's in it, because we're just going to count the elements. So we can use a wildcard type there. Whereas if we wanted to write a standalone add function, we take a list of some type, we don't care what type, but we also need an element of that list, rather of the type of the list. So since the type of the element has to match the type of the ilist, we need to introduce a type variable so that we can use it in both places. So that's why you would use a named type parameter as opposed to a wildcard. Any questions about that? Or you can also use the extends and super keywords to restrict the type parameter. So if you just have T in angle brackets, then it could be literally any type But if you need a more specific type, you can use extends or super to specify that. So 2 examples, if we have some method that does something with a type that extends my class, then we can now call some method that belongs to my class on the input parameter. So even though we don't know exactly what type T is, we know that it extends my class. It's a subclass of my class, which means that we can call methods that belong to my class on that object. So extends is giving you subtypes of a specific type, whereas super is going to give you super classes of the type you specify. So for the add numbers method, it takes a list of some type that extends, or rather that is a subtype of integer. So, I'm sorry, is a superclass of integer. So it could be a list of numbers, for example. Integer is a subclass of number. And then in the function, it's going to just add the integers 1 through 10 to the end of the list. So if it's a list of integers, then obviously adding integers is fine, but if it's a list of numbers, adding integers is also okay. So the wild card with super allows you to specify that something has to be a superclass of the type you specify. Do you see why we would use extends and super in these examples? Makes sense, okay. I think this is the last thing in my slides. So lambdas are just anonymous or unnamed functions that are particularly useful for functional programming. And you guys have used them a lot already in the labs. But I just wanted to kind of highlight the syntax, the different options for creating the lambdas. So the first option is the like the most compact, which is a single parameter followed by the arrow operator and then some expression. And you don't need any parentheses, it's just a single parameter and a single expression. If you have multiple parameters, then you need to have parentheses around the parameters. And you can also do a full-fledged bracket notation. So you have your parameter list, arrow, and then open curly brace, and then you can have multiple statements that have to return something, and then the close brace. So you'll notice that the parameters in the first 2 cases don't have types listed. That's because lambdas use type inference to determine the parameter and return types. So wherever this lambda is used, it will figure out what types x and y need to be, and what the resulting type of the expression is. But you can specify the parameter types if you want to. So yeah, any questions about lambdas or the syntax there? Okay. That was my last slide. So from here, I can just answer any questions you've come up with as you've been working through stuff, or we can look through some of the example code and just talk about what's going on. If there's anything confusing, where you guys want to take it from here.
I just have like a quick question. So anytime you're writing something inside of a class, do you just always use static, like public static or private static, or it could be something else?
So if you're making like a method or
Sure,
a data member, so if it's static, then that means there's only, so if it's a data member, if you mark it as static, that means there's only one copy in the class. And if it's a member function, then marking it as static means, so let's say you have class foo. And you have public static bar. So the way you would call this is just foo dot bar. And that'll call this function, so you don't need an instance. Whereas if this were not static, you would first need to declare an object of type foo. So foo equals new foo. And then you do lowercase foo dot bar.
Oh, okay.
So that's the difference there.
Then what about like with final?
So final has multiple uses. If you have a variable that you mark as final, then that means the variable can't change after it's initially assigned, or rather you can't reassign to it. So if you have final int x equals 3, and then you try to later do x equals 5, that won't compile. This is kind of the equivalent of const in some other languages. It's just saying that you don't want that variable to ever change. So you can use it for program constants. Final has some other uses. You can mark a class as final to indicate that you aren't allowed to extend the class. So if you try to extend a class that's marked final, that's a compile time error as well. You can also mark methods as final, and that means that in subclasses you're not allowed to override that method. So there are multiple uses for the final keyword that are all a little bit different.
Oh wait, one more question. Okay, so then when you're making like the methods for the class, how do we determine if we should use private or public?
So generally, the public methods are going to be things that you want the user of the class to have access to.
So private is just like something that is only needed like internally, like a helper.
Right. Yep. Exactly. It's a way of separating the interface from the implementation. Any other questions about this stuff? Do you want to run through some of the example code, or? Or is there anything you've seen in the code that you still don't understand, or anything like that? We could talk about these annotations. I didn't mention these in my slides. So here, these methods are explicitly marked as override.
Can you turn off the light?
Oh, yeah, sorry. So these methods are marked as override, which means that you expect these to be overriding some method in the parent class or interface. So list implements iList, empty, head, and tail are all methods in iList. And the purpose of using override, it's completely optional, because by default, when you create a function with the same name and parameters and return type, it's going to override the any implementations in the parent classes or interfaces. But that's just a way of telling the compiler, I expect this to be overriding something. So if you, say, had a typo and made empty return the wrong thing or typed the wrong name, then the compiler would tell you there's not actually a method that you're overriding. So that's what those are used for. I'm trying to see if there's anything else. Not null is another example of an annotation. And when you apply not null to the parameter of a method, then that will cause the compiler to generate a warning if you try to pass null to a call to that function. So a lot of these annotations are just ways of making your code safer, kind of telling the compiler what you expect out of your methods. Another example is you can mark a method as deprecated, and then if you generate documentation for the file, it will tell the users of the class that they shouldn't use that method because it's been deprecated. So a lot of these are just things for documentation or tools for the compiler to use.